Welcome. This video is over decimals and fractions equivalents. So let's look at our number routine. It says alike and different. Can you write down two ways these numbers are alike and two ways these numbers are different? Be ready to share when time is up. So I see the fraction of 4/5, 8/10, and 80/100ths. I'm going to create a chart, alike and different. What makes them alike? Well, they are fractions. I'll come back there in a bit. Different. The numerator slash the denominators are different numbers. That's one thing I notice. Let's go back to alike. 8/10. This is 8/10. Can I write 8/10 in decimal form? 80/100ths. If I affix a 0 right here, is 8/10 equivalent to 80/100ths? It is. What about 4/5? Can I build the relationship from 4/5 to 8/10 by 2? So 4/5 is equivalent to 8/10. So they're all equivalent. That's what I can say alike. They are equivalent fractions. So 4/5, 8/10, 80/100ths are fractions, but however, being more specific, they are equivalent fractions. What makes them different? They have different denominators and different numerators. So what we can do is you will need your own device. You'll be entering a code, and from this code, we're not going to be doing it right here, but if we had a code, you will be entering a number, and from this number, you will tell me what category does that go under. Does it go under counting numbers or natural numbers, whole numbers, integers, and behind here, and you can't see it until the game starts, rational numbers. So for example, if I say 6, how would I classify 6 as? I mean, it is a whole number. It can be an integer, it can be a rational number, it can be counting. But what is the best description of the number 6? A counting number, things you can count with your fingers. Since mankind started, we started counting with our fingers. What about 4? It could go all of them, but 4 is the best description for counting number. So 0 goes under whole numbers. What about -7? You can't count that with your fingers because it's positive integers. Not a whole number, so it would go under integers. This back here, I know you can't see it, it does say rational numbers. Rational numbers are numbers that can be written in fraction form A over B. So, for example, 5/10 is a rational number. What about the decimal? This. Can I rewrite this decimal in fraction form? 2/10. I can. So let's answer some questions. Can a whole number be written as a fraction? Can it? For example, I have 6, 4, so 6. Can I rewrite 6 in fraction form? If I do, what number would be in the denominator section? 4? Or would that change the value? How can I rewrite 6 in fraction form without changing the value of 6? 1, I have 6 pieces, or 6 positives, and I want to divide them into one group. So this stays 6, so 6 divided by 1. So the denominator is 1. So I can rewrite whole numbers and counting numbers as a fraction. For example, 8, 8 over 1. Here's our second question. Can the mixed number 3 and 1/4 be written as an improper fraction? What do you call this? Do you remember this from 5th grade? It's a number mixed with a fraction, so it's a mixed number. So what do you remember about turning this into an improper fraction? So you have 3 and 1/4. Going back to the modeling, for those who forgot, let's cut this in fourths. Let's shade in highlighter. Let's shade in 3 and 1/4. How many fourths did I shade in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or 3 wholes times fourths is 12, plus 1 more is 13 fourths. For those who forgot, this is how I learned it when I was a kid. Popcorn method, 3 times 4. So you multiply the denominator and whole number, add 1 more, 13 fourths. So what about 2 and a half? Can I rewrite this mixed number as an improper fraction? Here's the picture again. 2, cut them in halves. Let me use my highlighter and shade in 2 and a halves. So how many halves did I shade in? I shaded in 1, 2, 2 wholes times 2 is 4, plus 1 more is 7 halves. 2 times 2 is 4, plus 1 more is 7 halves. So yes, mixed numbers are rational numbers. They can be written as an improper fraction. So here's a chart. What's wrong with it? This is correct. Let's start with whole numbers. 5, 0, 3, and 2/5. I believe that is not a whole. That could be really written in fraction form. So I'm going to, I don't know why it came off. 3 and 2/5. Integers. Integers are whole numbers, which we already have right here, and its opposites. 2, opposite, -2, 7, no, 3 and 5/10. That can be written in fraction form. 3 and 5/10. So all of these can be written in fraction form. Again, this one can be written in fraction form. That's 17/5. So whole numbers, integers, and rational numbers. All right, so what you're going to be doing in the next activity is you're going to be getting a smart pal, and you're going to have a dry erase marker. I'm going to give you a little strip to tell you what fraction how many squares to shade in. For example, you may say, please shade 20 squares. So with your dry erase marker, you're going to shade in 20 squares. Then you're going to get 2 tiles, a yellow tile and a green tile. On the yellow tile, you are going to write down the decimal equivalents, and on the green tile, you're going to write down the fraction equivalency. So decimal. How many did I shade in? 20 out of how many? 100. So fraction will be 20 hundredths. And how would you say 20 hundredths as a decimal equivalent? 20 hundredths. And so I'm going to collect all the tiles, and then I'm going to, from everybody, then I'm going to redistribute these tiles to random people, and then you're going to walk around the classroom and find its match. And so 20 hundredths, 20 hundredths. Let's go back to 20 hundredths. Some students may take it upon themselves, and instead of writing 20 hundredths, they may write it by simplifying it to divide both numbers by 20, divide both numbers by 20, and get 1/5. So that's what they may have gotten instead. So let's do another example. What happens if yours says shade in 110 squares. So that's 1 whole square and this. So my decimal equivalency would be 1 whole square and 10 hundredths, or 1 whole square and how I write that? 10 hundredths. However, again, there may be somebody who may look at 1 and 10 hundred and simplify it down by dividing both numbers by 10 and getting 1 and 1/10. Let's think about it. If you look at this, 1 whole, if I cut this into 10 equal parts, would that be 1/10? It would be. So let's answer some question about this. Why did you select that decimal fraction? Well, the reason why I selected 1 whole, because it is 1 whole square, that's shaded, and the 10, and because it's using place value. This is in the hundredths place. So that's why I selected 1 and 10 hundredths and 1 and 10 hundredths. Knowing the simplified fraction, how can you use a 10 by 10 to help you find the decimal? So here's 1 and 1/10. So how can I use that? How can I use a 10 by 10 grid to help me find the decimal equivalency? And that is what we are going to be learning today. So for example, if I got 1 and 1/10, can I build this back up to a 100 grid? Because I'm going to use place value to help me. How would you build the denominator 10 to the place value hundredths multiplied by 10? So that's 1 and 10 hundredths. Let's go back, look at the other example. In this example, someone may have simplified as 1/5. How can I use this 10 by 10 grid to help me find a decimal equivalent using place value of 10 or hundredths? I'm going to use the place value of hundredths. Can I build 5 to 100 times 20 times 20? That is 20 hundredths, and the decimal equivalency is 20 hundredths. So look at this, 20 hundredths are shaded, or 1/5. If you don't see the 1/5, let me show you the 1/5. If I break this 10 by 10 grid into 5 equal parts, 1/5 is shaded, or 20 hundredths. Let's try another example. What happens if I got this? What happens if I got the fraction equivalency of because someone may have written on a paper, 1/25th? Can I look at this and figure out the decimal equivalency? Is 1, 2, 3, 4 hundredths. But how can I get the decimal equivalency 4 hundredths from 1/25th? Again, using place value, this is a hundredths. How do I build 25 to 100? Times 4, times 4, 4 hundredths. And 4 hundredths is shaded. So now that we know our place value a little better, can you use this place value chart to help you answer these 3 questions? 0 and 7/10. Can you rewrite this in fraction form? 7/10. Where would you find 7/10 here? A little more than half, or a little less than half? Just a tad bit of a little more than half. Next example, 35. What place value? In the hundredths place. 35 hundredths. And where would you find 35 hundredths? Would it be a little less than half, which is 50 hundredths, or a little more? A little less. It goes right here. Can you simplify 35 hundredths, though? You can. What can I divide 35 and 100 by? By 5, I get 7/20th. Next one, 4 and 34 is in the hundredths place. How would you rewrite that as a fraction? 4 and 34 hundredths. But can I simplify that? What can I divide both numbers by? By 2, 17/50th. 4 and 17/50. And where would I place it on this numbered line? Between what 2 numbers? I would place it between the 4 and the 5. The last activity we're going to do is given a fraction. Oh, last one activity today. As a group, you're going to talk to your group with your dry erase marker and answer this. You have $4. 1, 2, 3, 4. You're going to split it evenly among 5 friends. How much money will each person get? I have $4. I'm going to divide it evenly among 5 people. Well, first of all, is it going to be more than a dollar, equal to a dollar, or less than a dollar each person? I believe it's going to be a little less than a dollar. So, can 5 go in 4? 0 times. Can 5 go into 0? So, oh, stop. I forgot to subtract 4 minus 0. Can 5 go in 40? 8 times. Bring down to 0. Can 5 go in 0? 0. So it is 80 cents. So this person will get 80 cents, 80 cents, 80 cents, 80 cents, 80 cents. To check your work, 5 groups of 80 cents is $4. Well, because of this, you just learned how to turn a fraction into a decimal. So you have the fraction 4/5, which is really equal to 4 divided by 5. And is 4/5 more than or less than a half if you had to make a prediction? Let's think about it. If I had a circle and I cut it into 5 equal parts and I shaded 4 of them, that would be more than a half. So I think 4/5 would be more than a half. But what is a decimal equivalency? There's 2 ways to solve this. You may do division or use place values. Some people prefer place values. Just think about the 100 chart we did earlier. Can 5/5 be built back into a 10 by 10 grid? What's the relationship? Times 20. Times 20. That would be 80 hundredths, and that's the decimal. Let's go back here. Did we get 80 hundredths? We did. That's one way. Or we can divide 4 divided by 5. Can 5 go into 4? 0 times. Can 5 go into 40? 8 groups. And we're done. So 8 tenths, if you affix a 0, 80 hundredths. Let's try another example. You have $3. I want you to split it among 4 friends. So would each person get more than half or less than half? Let's think about $3 and you're dividing it among 4 friends. Each person can get less than a dollar. So I have $3 and I divide it evenly among 4 friends. 4 going to 3, cannot. Bring down to 0. Can 4 go in 30? 7 times. Bring down to 0. Can 4 go in 20? 5 times. So 75 cents. Each person will get 75 cents. Well, we just did this example if you did not know that. 3/4. Is 3/4 more than a half or less than a half? It is more than a half. So what is the equivalency? Again, 2 ways to do it. You may use place values. Think of the 10 by 10 grid, 100. Can 4 be built into 100 times 25? That'd be 75 hundredths. Or some kids prefer dividing 3 divided by 4 or 3 divided by 4. And 4 go in 3? None. So add annex a decimal and a 0 since it cannot go in. Bring it down. Can 4 go in 30? 7 times. 2 is our remainder. Annex another 0. Bring it down. Can 4 go in 20? 5 times. So that's where I get my 75 hundredths. The next example, you have $9, and I want you to split it evenly among 20 friends. Whoa. Will each person get a dollar, more than a dollar, or less than a dollar? I predict way less than a dollar. So if I had $9 and I divide it among 20 individuals, Can 20 go in 9? 0 times. Can 20 go in 90? 4 times. Can 20 go in 100? 5 times. So it's 45 hundredths, or 45 cents per person. If you didn't realize, we just turned this fraction into a decimal. I got 4,500, which is little less than half. Goes right here, closer to half, a little less than half. So 9/20th. Um, Two ways to find the decimal equivalency. Do you like place values? I like place values. So let's build this to a hundredths place. How do you build 20 to 100 times 5? That's where I get 45 hundredths or 45 hundredths. Some people prefer, however, to divide. 9 divided by 20. 9 divided by 20. Can 20 go in 9? 0 times. Our remainder is 9. How can I get rid of this remainder? I annex a decimal and a 0. So bring it down. And 20 groups go into 90. How many groups of 20 go into 90? 4 groups, 20, 40, 60, 80. I have 10 left over. Annex another 0. Can 20 go into 100? 5 groups. And that's where I get my 4,500s. Our last question is this one. You have $7. I want to split it evenly among 4 friends. Will students get more than $1 or less than $1? I say more than $1. So $7 divided evenly among 4 friends. It goes in 1 time. 7 minus 4 is 3. I bring down to 0. Can 4 go into 30? It goes in 7 groups. 2 is left over. Bring down to 0. Can 4 groups, how many groups of 4 go into 20? 5 groups. And that's where I got $1.75. If you didn't aware of it, we just solved this problem. Was it $1.75? Yeah. Would that be between right here? Here's another way. If I had to, there's another way you could solve it. Using place values. How can I build 4 to a place value of hundreds? How many groups? Times 25. That's where I get 175 hundredths, 175 hundredths. Another way I could have done it is this. Do you remember how to turn an improper fraction into a mixed numbers? How many 4s go into 7? 1 group. If you cannot do it in your head, how many 4s go into 7? 1 group. You have 3 left over. How would you write that fraction form? 1 3/4. And we know 3/4 is 75 hundredths. So that's why we know it goes right here. And another way, if you don't want to do it that way, that's why math has so many different ways of doing it. So you may use place value of 100. You may turn this into a mixed number. Or you can just divide 7 divided by 4. And 4 groups of 4 go in 7, 1 time. Remainder is 3. How can I get rid of this remainder? Annex is 0. Bring it down. How many groups of 4 go in 30? 7 groups. 2 is left over. Annex is 0. How many groups of 4 go in 20? 5. So that's where I get 175 hundredths. So what we just did is we're given a fraction. From this fraction, you can use place value of hundredths, or you can divide the numerator by the denominator.